Hi, this is Jeff Heaton. In this video, I'm going to talk about how to do 3D graphics in Python. We're going to look at some of the different ways to do this. Now, you need to think about what your end objective is. Are you trying to do something real-time like a video game? Do you want something that you can potentially move to a mobile device? Do you want something where you're rendering to files? And it doesn't necessarily matter that you're generating these frames in exactly the rate that they're going to actually eventually be displayed at. So let's look at the different ways that you can do 3D graphics in Python and get an idea of which one is going to work best for your intended application. To see all my videos about Kaggle, neural networks, and other AI topics, click the subscribe button and the bell next to it and select all to be notified of every new video. So before we start talking about 3D in Python, let's talk about 3D outside of Python. So if you're creating a hardcore video game, which is not what this video series is about. I'm a data scientist, I'm a machine learning guy. I want 3D for visualizations. Maybe the closest I'm going to get to a video game is creating output for like an artificial world type of thing generated by a neural network, kind of GAN-like, or perhaps a cellular automation. But if you're looking for hardcore create a game, kind of the two big ones that at least I hear a lot about would be Unity first, and I've seen colleges use this even as kind of an intro for 3D programming. This is a game engine, so this does not make you deal with some of the lower level stuff that you're going to see if you're dealing with OpenGL or, heaven forbid, Vulkan directly, and I'll talk about what those two are in a moment. And then it just lets you also interface into some of the things like on mobile platforms where you're going to want to deal with maybe in-app purchases and other things. There's just kind of a whole framework there that makes that a little bit easier and more direct. Again, things I'm not interested in for what I'm currently working on, but this is something worth looking at. Now these are all going to be heavy C++, although you can use C# for Unity. Perhaps the other one would be Unreal, definitely to be aware of. There might be Python bridges into these, but I'm really not going there or dealing with that at this point. Now, this is not to say that you can't use languages other than C++ to write video games. I mean, I love C++, but it's a total pain in the word that would maybe demonetize this video. So you can certainly, Minecraft, at least before Bedrock, was written in Java. And Python, EVE Online, which I am not much of a gamer, but I did play EVE Online for a while and did enjoy that. You build spaceships and blow each other to other word that would get me maybe demonetized. So this uses stackless Python, which is really interesting, and I might do a video on stackless Python and maybe Cython just to talk about kind of the extreme performant variants that are available for Python. But let's not talk about games. Let's talk about how you can get 3D looking stuff incorporated into your Python programs. And there's really 4 ways that you can go about doing that I'm going to talk about in this video. Going from perhaps the most mathematical, data science-y to much closer to the video game world. We'll start with just using Matplotlib, which really has a lot of 3D capabilities in it. After Matplotlib, we'll take a look and go a little bit more low level and deal with Blender, which is used very much in the video game industry. But I like Blender because very often what I'm wanting to do is not necessarily do something real time. I'm wanting to output either images or create a video that I'm going to mix in Adobe Premiere or something like that with my YouTube videos, because I'm a YouTuber, so I don't necessarily need to do this stuff real time in screen capture. In fact, screen capturing in high performant video operations can be a pain. Often I just want frames and then I'm going to FFmpeg them together. And I've got another whole video on FFmpeg if you're interested. It's a cool utility to link together images, almost like a cartoonist, each frame, into a video. So and Blender, by the way, has Python completely built inside of it. You can execute Python scripts inside of Blender or even use external Python environments. I've done a fair amount with Blender and Python. I definitely will have a video coming out on that and how to use Blender for some higher resolution, very interactive, very immersive type visualizations. Then going on from there, we'll look at OpenGL. And OpenGL is very low level. You can go even more low level than that and even to Vulkan. But OpenGL and its counterpart in the Microsoft world, DirectX, you can access both of those in Python, and we'll see how to do that. I'll probably have some custom videos on that because I really enjoy OpenGL. And then looking at maybe you do want a game engine, and a game engine goes a step higher than OpenGL. It uses OpenGL typically and lets you not have to deal with figuring out faces and normals and shaders and all the fun stuff that goes with OpenGL, but focus more on rendering perhaps your meshes in something like Blender and pulling them in. And the game engine I'll talk about for Python is Panda, not to be confused with Pandas. If you have just one Panda, it's a game engine. And then finally, we'll take a brief look at Three.js, which it's not Python, but I use it often in conjunction with Python because it lets me render right to a web page, and that's valuable because nobody has to install anything. It is just there on my page for people to look at. And I'll show you some of the things that I've used that for. So let's start with Matplotlib. If you're a data scientist or machine learning type person in Python, you've almost surely dealt with Matplotlib. It's basically Python's implementation of MATLAB's plotting engine, which is quite good. I love Matplotlib, but I also really find occasionally just tweaking it and getting every little thing on my particular diagram really annoying at times. But as such is the world of plotting. Definitely lots of those explicitives that would get me demonetized when I work with Matplotlib. So if I do a video on this, I have to be careful. But Matplotlib, essentially, you can add in that third dimension. And now you can do line plots in 3D, and it renders it somewhat isometrically, so you're not necessarily getting distance like you would be dealing with in some of the other environments that I'm going to show you. And you can do a lot of neat things. Where I really like to use 3D in particular is surface plot kind of contours, where like this, where I'm showing the relationship maybe between an X and a Y, and Z is the magnitude at each of the intersections of those. So maybe I'm trying to optimize a two-variable function that accepts an X and a Y, and I'm just plotting it, and I'm looking, okay, here's the minimum, here's the maximum, at least locally for this amount of area that I plotted it for. And there's all kinds of, you can also represent it this way. This is usually how I will plot an X versus Y relationship in 3D, but definitely a variety of things you can do here. This is just a link to the Matplotlib 3D capabilities. I'll put a link to that there. I'm not going to create a specific example of my own for Matplotlib 3D. There's a ton of them out there. I use it occasionally. Blender. So Blender is neat. Blender lets you deal with Python directly, and Blender's amazing. It's pretty much access to Hollywood level 3D rendering, assuming you have the skill to do Hollywood level 3D rendering, which I do not. I'm a machine learning guy. I aspire to give my machine learning creations skills in art and music that I personally lack. Artificial intelligence is for those who don't have those skills. So that's why I've always been drawn to it. So some of my books that I've done in the past, I've used Blender. So this was rendered in Blender. as was this, and as was this. This I hired a graphic artist. And by the way, did not look closely enough at it. If you notice, this equation is actually wrong, it's pretty, but it's wrong. Maybe if it would have been right, I would have had 5 stars, but whatever. So let's look at Blender. So if you just open Blender, this is the classic screen that you see where you've got a 3D cube, you've got a camera that is looking at it, arrow to tell you which way is up, because everything's relative. Up is only what the camera says is up, and a light source. So you can then go and render this thing, and voila, there's your 3D cube. Why does every 3D example always start with a cube? Nonetheless, you have the ability to actually use Python code right inside of your Blender file. And this is a program that I created to render 3D block towers, kind of like this one that you see over here. And all this code that you see is basically placing these building blocks onto the scene. And everything you do in 3D programming is a scene. You're setting up a scene so that you can take a picture of it. Then you build the next scene, take a picture of that, and that's basically how it works. Now I can render this block tower, and this was something I was trying basically to give my students so that they're supposed to predict if this block tower is stable or not, because Blender has physics in it. So you can take these block towers and run physics on it and see if they're going to fall or if they're going to stay up. Now that one was not supposed to all be in purple. If I run these, it basically loops through and generates the way that this script was written, it generates a large number of these images with the blocks at different angles, different lightings, and different blocks. So I randomly build this building up each time. Sometimes I might leave out blocks, and just to show you, this building is unstable, so let's run physics. Look, it collapsed. And I can create very, very complicated images that get destroyed by various means. So this was just for a Kaggle competition that I ran with my students, where they were supposed to predict, given all these random angles and lighting and whatnot, is something stable or is it not stable? Moving on from Blender, the next one that we'll deal with is OpenGL. Now there's a bunch of ways to do OpenGL in Python. A lot of times you'll use PyOpenGL. PyOpenGL has been around a long time and it's great, but it just does the OpenGL. To actually display it, you need to embed it in something like a Pygame. One of the issues that I've always had with OpenGL is, and if somebody knows a better way to deal with this, I'd be quite interested to hear about it in the comments. But OpenGL, what I'm often doing is I'm not rendering to the screen. I want to render it to a file, and Blender makes that wonderful. And I can then place it out in a directory somewhere, whereas OpenGL is really more along the lines of like a game. So for this kind of thing, if I was using Pygame, I had to essentially do almost a screenshot inside a Pygame and render it onto the screen, but then you have to do all kinds of hokey things like make the window invisible, and you're rendering to an invisible window. And then what if I just want to run headless and run this on an AWS EC2 instance, because I'm going to render a ton of these. So it's not the intended purpose of it. You can definitely make it work, and I have made it work with Pygame. But the library I currently like the best is GLFW, which has both the OpenGL and even Vulkan if you want to. And Vulkan is the real low-level version of OpenGL that is even more difficult to use, but it gives you more control. So here, and this is an example code that I grabbed from OpenGL. This is not my own creation. Here you're creating a cube. You're creating all the vertices to essentially create a mesh to define the cube. The indices define which of these various vertices you're using. So there's eight vertices, which are then essentially the two rectangles that you would think of for the cube. And then the indices, these define all of the lines that you draw between the vertices to form the edges. OpenGL is very low level, so you've got to deal with normals, which is essentially lines projected from the faces, because the faces defined by these vertices they're always planar in that they're not an irregular shape generally. So you have to calculate this perpendicular orthogonal sort of line that comes right off of your faces, which that way it knows which way is up so that the lighting can work properly, but it gets to be a pain. You also have to define your own shaders, unlike in Blender where I'm just saying, hey, here's the image, that's the texture or the picture. It works better. It's easier, fewer steps. So you have to compile these shaders, and this is a whole thing really in video game programming, and I have not gone deep on video game programming by any stretch of the imagination. But you build this whole thing up with these fairly low-level constructs in OpenGL. Definitely the thing I like about OpenGL is it is a constant. It's a standard. So I've been dealing with OpenGL in various forms since I was an undergraduate student. So if we run this program, you'll see it creates a cube, and that's pretty nice. You can see the cube rotating. It's kind of funny. It kicks in NVIDIA because it says, oh, you must be playing a game. But no, I'm not. So these are the shaders that are giving the faces of the cube their look. And OpenGL exists in a lot of forms. I've done OpenGL in C++, in C#, in Java, JavaScript. It's like a constant across the continuum of programming languages. And the same group that produces OpenGL also produces OpenCL, which is a great concept. It just doesn't have the support in the machine learning world that CUDA does. So it's just essentially a way to use GPUs as compute processors. I spent a lot of time doing OpenCL back when I was doing the NCOG project and learning C99, which is their variant of C, where you would essentially program the OpenCL kernels that you would use for your machine learning. So if you look at these shaders, this is essentially a little language. I don't know if this is C99, but it's definitely close to it. This is very much the foundation from which you're using GPUs in machine learning sprung, because you would program in the shader languages little programs that would shade these faces of these 3D objects that you're dealing with. And somebody at some point got the bright idea that this math is pretty similar to what machine learning is doing, linear algebra type of stuff. And here we have GPU as the driving force for deep learning. If you want game engine and you want something closer to Blender, where you're dealing really in primitives, more like cubes, spheres, toruses, rather than dealing with faces, vertices, then Panda 3D might be a good option for you. Not to be confused with pandas, which means an entirely different thing to machine learning world. This is pretty good. I've dealt with it a bit. It seems like the support or the activity on it has gone down a bit in recent years, but it's still quite actively supported from what I can see. And you can create a variety of very cool video games in Python. Very often you'll probably be creating your meshes, your objects in Blender or something like that, and importing them into this or importing them into OpenGL. But this is a way that you could have a very interactive Python 3D program. So another thing that I'll talk about is JavaScript. So JavaScript, you can use OpenGL, and I like this in particular because I could use it with some of my books where basically I can just give you a link and you can be running an application entirely in the web and not have to install anything. So this is a flocking algorithm that I put together that basically uses 3D to allow you to watch the flocking occur in three-dimensional worlds. Now you can do all kinds of fun things with this. You can change the view so that you can do a ride along. So now I am inside of one of these ships, so to speak, watching the flock go on. But fun kind of stuff to work on. MergeLife is something that I built that creates cellular autonoma and cellular automations, and this lets me on my website have just basically a whole gallery of all kinds of interesting virtual life sort of creations that my algorithm came up with. So it's kind of like Conway's Game of Life, except I didn't create any of these. I mean, I am nowhere creative enough to create Conway's Game of Life, but maybe having a machine learning algorithm that creates these kind of things might be more what I would be capable of doing. So there you have it, some of the ways that you can do 3D. So this was just a high-level overview video. I did not get too much into the coding, but if you're thinking of using 3D in Python, these are some of the things that we'll look at. I will definitely follow on with a Blender video showing how to use Blender in conjunction with visualization and the kind of things like you might do in machine learning. Maybe OpenGL as well. I don't know. Let me know in the comments if you're interested in that. I don't often need... Usually if I want that level of interactivity, I'm going to be dealing with it in Node.js. Or not Node.js, because this is actually browser JavaScript. So if you want to see that by any means, how to do visualizations in JavaScript, kind of using Python to create it, because I'm primarily a Python programmer at this point, but I will use JavaScript because it's the gateway to the web essentially. Thank you for watching this video. In the next videos in this series, we're going to look at some of these individual techniques that we talked about while we were looking at the different ways of 3D programming in Python. And of course, if you're interested in AI and this sort of thing, please subscribe to my channel. Thank you very much.